We have a lot of numbers in this problem. We may or may not use all of them. Let's get right to the question. So the problem is asking us to calculate the number of moles of H2O, and we're told that this reaction goes to completion. In other words, it's not a reversible reaction. Let's start by writing the equation. Looks like this is a stoichiometry problem with some gas law calculations embedded. So we're told this is a reaction between methanol and oxygen, and that's a gas under these conditions, and that produces carbon dioxide gas and water vapor. Let's start by balancing this equation. We're going to balance the oxygens last because it appears in multiple locations on both reactants and products, and it's also isolated, so we have the most control over that. The carbons are already balanced. Let's work on the hydrogens. We have 4 hydrogens on the reactant side. Let's put a coefficient of 2 in front of the water to balance out the hydrogens. Now let's balance the oxygens. On the reactant side, we have an odd number, and right now we have even number on the right side. So let's start over. Let's double the carbons. So the carbons are balanced. Let's work on the hydrogens now. By doubling the methanol, we went from 4 to 8 hydrogens on the reactant side. So we're going to need a coefficient of 4 in front of water to balance out the hydrogens. Finally, let's balance the oxygens. We have 4 oxygens from the water molecule, 4 oxygens from the carbon dioxide. We have a total of 8 oxygens on the product side. We have 2 from the methanol, so we need 6 more. We can get that by putting a coefficient of 3 in front of the O2. So there's our balance equation for this reaction. So the answer is going to be in terms of moles of H2O. Let's see how many moles we have of methanol. We're given volume in milliliters, and we're also given density. So notice, because we're given density, we're able to get the mass. And we know if we have the mass, we can use the molar mass to convert to moles. Let's do that. Start with what you're given. That's 50.0 milliliters of methanol. Use the density as a conversion factor to convert milliliters to grams. So in 50 milliliters of methanol, we have 42.5 grams of methanol. Now that we have mass, let's use the molar mass to get moles. Methanol has 1 carbon. The carbon's molar mass is 12.01. It has 4 hydrogens. Hydrogen has a molar mass of 1.008. That's going to be 4.032. And there's 1 oxygen. So there's the molar mass of methanol. Let's use that to convert grams of methanol to moles of methanol. So we have 1.33 moles. So So let's see how many moles of water we can form with this amount of methanol. I know what some of you are probably thinking. We can write out all the steps and then punch in all the numbers at once, and that'll save you some time. So I'm doing this so I can break this down into steps. So step 2 is to use the mole ratio from the balanced equation to convert to the desired substance, which is water. All right, so the mole ratio here is 2 to 4. So we can make 2.65 moles. Of water. I'm going to circle that for now. It's not our final answer. Now let's see how much water we can make using the other reactant. Now the other reactant we're given is volume of a gas. Now you might be tempted to use the molar volume, but the molar volume only works under standard temperature and pressure. And we don't have standard temperature nor standard pressure. So we'll have to use the ideal gas law to get the number of moles. The ideal gas law is PV equals nRT. And we want to rearrange this to solve for number of moles. We're given pressure as 2.00. Let's see, what is the volume? So the volume is given to us in liters, 22.8. The universal gas constant we need is the one that has atmospheres in it, so we can cancel out the atmospheres. And then temperature we need in terms of Kelvin. The temperature we're given is 27 degrees. Let's add 273 to that. And that'll give us 300. All right, kelvins cancel out, liters cancel out, atmospheres cancel out, and we have moles on the denominator of a denominator, so we can reciprocate it to the numerator. So 22.8 liters of oxygen under these conditions is 1.85 moles. Now let's take that and see how much water we can make. So the mole ratio between oxygen and water is 3 to 4. So we can make 2.47. Moles of water, given this much reactant of oxygen. So O2 is the limiting reactant. And therefore, the theoretical yield is 2.47 moles of water.